Howdy and welcome back for part two of the first lesson ever. I understand the last part, it ran a little longer than I expected, and I apologize for that. I'll try to keep it a little shorter and perhaps a bit less rambling here and there. So, language syntax and semantics. So, my whole kind of goal with this is to just briefly talk about some of the components that comprise a language such as C++. So languages are going to be composed of a set of valid sentences. This doesn't matter if it's English, French, Russian, etc. A valid sentence is simply one that is syntactically correct and semantically sound. In other words, sensible. Syntax is going to be to the actual underlying structure, whereas semantics is going to be to meaning. Programming languages, like the English language, have grammars that dictate which sentences are syntactically correct. What we'll see here, and which will be a source of perhaps bugs in your applications, is that you can have syntactically correct sentences that are semantically incorrect. And we'll see some of the implications of that. And that could be a result of multiple things within your program that should that occur, but we'll get around to that. But let's begin looking at just language syntax in general. The smallest piece of a programming language that is going to have meaning is going to be known what's as a token. In English, a token is going to be like a word or punctuation mark. Many tokens in C++ are going to be words. Others are going to be symbols like punctuation. If you change a token in C++, you would change its meaning. And this you can think of as being similar to breaking up a word, which can result in something that is no longer a word. So kind of the next step up from tokens is this idea of expressions. So in English, we have phrases that are built from words. In C++, the equivalent of a phrase is going to be an expression. An expression is simply a group of tokens that yields a result when it is evaluated. For instance, 3 plus 3, 6. In C++, some tokens are going to be interpreted as operands in an expression. So in the previous example, the 2 threes. Other tokens are going to comprise operators, such as the plus. The simplest form of an expression is going to be composed using one or more operands that yields a result when evaluated. So that could be something like 7, evaluates to 7. More complicated expressions are formed by incorporating an operator in one or more operands, -7, 3 plus 3. In English, putting phrases together builds sentences. And a sentence is going to be a grouping that stands on its own in written English. I wanted to jump right into a statement. The equivalence of a sentence in C++ is a statement. A statement is a complete and meaningful command that can be given to a computer. In C++, a semicolon denotes the end of a statement. 3 plus 3, semicolon. That would be a statement. 3 plus 3, not much, just an expression. In English, we end sentences with a period or some other punctuation mark. Same kind of idea here. Now moving on. So we kind of know what statements are now. There are sentences in our programming languages. What about semantics? The underlying meaning of those statements or sentences. In English, a syntactically correct sentence does not imply that it is semantically sound, that it makes sense. For instance, this is completely grammatically valid. Our black cat is yellowish brown, yet it doesn't, it doesn't make sense. How can you have a black cat that is yellowish brown? I don't know. In C++, a statement can be composed with correct syntax. And the reason why I'm pointing this out is because what we're going to see is the compiler will check to ensure that all of our statements follow the correct syntax. Where I believe our runtime errors are going to start to arise and logic errors are going to be when we have kind of semantically incorrect statements where perhaps it's doing something that goes against our expectations, might be one way to phrase that. So essentially what this means in these scenarios is that the statement is not doing what the programmer intended. And that could be a fault of a statement we wrote explicitly. It could be the result of the usage of a library that we didn't correctly interact with through an interface. There's a number of different ways that we could have things happen that's not what intended. But the consequence of this is that your program could crash, could produce the wrong value, or it could perform a behavior incorrectly. Any one of these, is a plausible result due to, having these sorts of semantically incorrect statements within your applications. So that was a little quicker. I hope that, gave a positive overview of, what we mean when we're referring to language syntax and how the syntax differs when we're speaking about language semantics.